Hi everyone, welcome to our event. This event is brought to you by DataTalks.Club, which is a community of people who love data. We have weekly events, and today is one of such events. If you want to find out more about the events we have, there is a link in the description. Go there, click on this link, and you'll see all the events we have in our schedule. Do not forget to subscribe to our YouTube channel. This way you will not miss out on any future streams as awesome as this one today. And we have an amazing Slack community where you can hang out with other data enthusiasts. So check it out. If you haven't registered, do it now. And during today's interview, you can ask any question you want. There is a pinned link in the live chat. Click on this link, ask your questions, and we will be covering these questions during the interview. That's all. I think if you wake up me at, 2 a.m., I will be able to say what I just said without, turning my brain on.
Can I pick on you for a little bit and say, if you do have a Slack that's full of data that I can hang out with?
Okay, yeah, good suggestion. So recommendations and feedback are welcome. So now I should open the questions we prepared for you. And I guess start, right? If you're ready.
There's no time like the present.
Okay. So this week we'll talk about industrial data challenges. And we have a special guest today, Rosona. Rosona is a trained mathematician who works in the data space for the last 6 years. And with last 3 working in industrial data. She is currently a machine learning engineer with technical leadership role around synthetic tabular data in an AI innovation team. And she's particularly intrigued by industrial R&D problems. And welcome to our event today, Rosona.
Thanks for the invitation. I'm glad that that finally worked out. We've been trying to schedule this
for a year or maybe more. It was always fun.
March. It was
with you. Yeah. Well, anyways, so every time we spoke previously, you always had an opinion about many interesting topics. So today we finally have a chance to put this on the record and have a podcast interview about that. The questions for today's interview are prepared by Johanna Bayer. Thanks a lot, Johanna, for your help. And before we go into our main topic of industrial data challenges, let's start with your background. Can you tell us about your career journey so far?
I mean, you gave sort of the broad strokes, right? I was originally a PhD mathematician. This is actually what brought me to Germany, was an academic career. I did several postdocs, first in Hamburg. And you reach a point where either it's going to work or it's not, relative to your constraints in your life. And so I decided, okay, industry it is. And then that's been about 6 years. I've tried many roles. I sometimes tell people looking at my career path looks kind of like I'm a data Roomba. Like, let's try this. I go with this direction. I hit a block. I spin around. Roomba, you know those vacuum machines that you don't. A robot that cleans your house. Except I'm, that makes me sound like I'm a data cleaner by trade, which I'm not. But I mean, just sort of like there was intention, which is more than I could say for a robot, I guess, but or this particular robot. But I explored a lot of things, and each time I pivoted, someone on LinkedIn was saying, have a goal, and then you have to keep pivoting. And yeah, sure, but you should also adjust the goal as you go. Before you get in industry, you don't really know what it means to be in industry. So, right, and anyway, mixture of things: financial data, CRM data. And then industrial data about 3 years ago, a contract position for about 9 months to a year, and then where I am now permanently. And I think industrial data, this is something that's really frustrated with me, and why I wanted to do this topic is I feel like we're ignored by a lot of tools and a lot of demos, and you get kind of tired of being that person in the audience being like, but what about our use case? So I'm here to say, we have all of these data. It's cool. We have great challenges. If you're looking for a new area, or in the future, what might you do in industry? This is a great place that I think is underrepresented, maybe in the space of events. Also, caveat, I have to say, I'm here as a private person, so none of my opinions are those of my employer. I will do my very best not to use profanity, but I make no promises.
What did you actually research as a mathematician.
Oh, I meant to have a prop. Can I get off camera and come back? Is that okay?
Okay.
All right,
Yes.
I'll be right back.
I'm really curious what happens next.
Originally, I was going to be at my desk, and I would have had this there, so I didn't plan for that part. This is the shortest answer. And if
For those
my
who do not see the video, because we will also release
yes.
it as audio only. So what is that?
I actually don't know. I
For
was
those
thinking
who
it was a
see the video,
Möbius band.
also maybe people wonder that. Is it like
so these are
stripe?
3D printed topological spaces. This is an inverted sphere, and then I think this might be a Möbius band. It might
stripe,
not.
right?
Yeah, I think so, but actually I think it's like equivalent, but it's not actually the same. Like geometrically it's different, but topologically it is. So that's the long answer to the short answer of I was an algebraic topologist. I was way off in like the far. Have you seen the XKCD where he's got like applied fields and he's got, I don't know, like sociologists, scientists, but blah, 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 engineers. And then way over here is mathematicians. If you did the same graph and then, but inside of mathematics, I feel like topology, especially algebraic topology, especially my like sub discipline is similarly like way off the deep end. Like, hey guys, we're over here. So the study of spaces and some people call it rubber sheet geometry. It was fun. I liked it.
Inverting spheres.
Inverting spheres. There you go. Yeah. There is actually applied algebraic topology, but that's not what I did. But if you're excited about, hey, this sounds cool, what can I do? Maybe go that way. I could name my first advisor was Rob Greist, who I then changed to more pure discipline. But he's a lot of cool presentations.
So what of this was you had a lot of still know a lot of mathematics. What of this mathematics was actually useful for your industrial career?
Sorry. I should. This is not fair because this is totally not a question. It's also a little mean. I feel
okay,
like.
I'm sorry. We can skip that one.
No. It's fine. It's fine. It just reminds me. I had this interview with a group of, I'm not gonna name obviously the employer, but a group of applied mathematicians. And I came into this interview and they're like, "How did you end up in IT?" I'm like, okay, hostile environment.
Because I'm curious, like probably it was very useful when you were picking up some basics of machine learning, but maybe not all of that, right?
Yeah, but I think this is also a deeper question of how is mathematics useful and what is mathematics. And I think I'm dead serious. Give me I'll stick it to address this. I think most of what we learn in school of mathematics isn't mathematics, and what really is mathematics to me is thinking logically. And what I bring, so really another question that I like better is, what do you bring as a pure mathematician into this space? And I think it's really in math, especially in pure math, and a really niche discipline where people are not willing to repeat themselves. You have one chance to learn something from someone, right? You're at a conference, there's that fancy guy over there, and you're like, oh my God, he wrote this paper, or she wrote that paper. I need to talk to them. And you have maybe 40 minutes of their time if you're lucky, probably 20, maybe 10, right? And you have to optimize like the thing I want to know and what questions to ask, and like, have I answered these questions? And these are really valuable skills. I think just going in and understanding what questions to ask, how do you learn enough about something to sort of keep a model of it in your head, and then here's the pure math part, say, how is this going to break? Because this is the difference between a proof and a simulation. Like when you try to prove things, you're actually not trying to prove something. I'm not out there being like, here's my argument for why you should vote this way. I'm out there trying to first see, why will this fail, and then fill those holes. And that's incredibly valuable. And I think the biggest thing I bring as a pure mathematician is this proof viewpoint.
Okay. For how long did you actually do this?
Academics.
I mean, mathematics, yeah.
Oh, haha. I mean, you mean from the point I decided to study pure mathematics? That was like 2 years of undergrad plus 7 years of master's plus PhD plus 6 years of postdoc.
Okay, that's a lot of mathematics.
It's a lot. It's a full career. I think this is also something that makes it really difficult jumping to the end of the talk to what's it like being, what's this transition like? I think it's people don't know where to put you, right? Because you're lopsided, right? You have this whole career in a completely separate space. So you're a senior, you're obviously senior. I mean, look at your age, look at how long you've been working, but you aren't senior in a business sense, right? There's a lot of things you don't know, right? You come in and maybe you don't know SQL or whatever. You can learn it, obviously, but you're this weird lopsided human that people have to figure out how do I deal with this development of this person.
Yeah, if you can invert the sphere, then SQL is like peanuts, right? It's very easy to pick. Okay. So we actually here wanted to talk about industrial data. So what is industrial data? What is it?
So let me first make a caveat that I really like this topic. I've been working this topic, but I think there are obviously people who are super experts on this. So before I offend anybody, industrial data is not a monolith. And this is, I think it's a great question. What is it? And it's very broad. So let me say the simplest answer is a productive industry generates the data, and it's data
That's
that
pretty
doesn't.
much everything, right?
But
Like
not really,
in
right?
all the
CRM data.
industries.
I fight that CRM data does not fall under this. HR data does not fall under this.
Okay,
Obviously, we have this data,
why
but
it does not fall into? There is a
because
process
it's
that generates data, like somebody is hired, then okay, there's a new record.
sure, but it's not like I have a thing that I'm trying to make. So I mean, like in the industries like the chemical industry or the semiconductor industry or our friends in the automobile industry, like people who have a thing that they sell at the end of the day,
Like a
that they
physical thing, a
produce,
process or
a
something like that,
physical
right?
thing that they
Not necessarily
produce.
like a program.
Not a program, not a person, not like recommendations on a website, like an actual physical thing.
So it's like if there is I don't know, I want to create paint, blue paint, right? There is a
Right.
process for creating the paint. And there is some data produced by this process.
Yes.
And when you work with this data, this is industrial data, right?
Right. And then within industrial data, I just want to like R&D data, which is small, which is why there's this like, oh, small R&D data, because that's where I've historically been sitting. But I've been sort of half. I've also done some of the what I would call the productive. So there's sort of industrial R&D where experiments can be very expensive, which is why it's small data, because it's expensive. And then you generate a process, you develop a process for a new product. And then there's like a pseudo plant where you do this, you run the process with a lot of Q&C, a lot of stopping it, like adjusting things, like your
Q&C.
QC, quality control, where you stop it. Good call. I'm usually better about abbreviations. Right. So you stop it and you adjust it and you're developing the process of making the thing, right? Step one, here's the formulation for the thing. Step two, how do we actually do it? And what information do we need to record to make sure that it's produced at a good quality? And then step three is we've developed that process, we've got it live, it's running. And then there's live quality controls that you have to do. Like this machine has a part that welds and it needs to be replaced regularly either because it wears out. How often does it need to be replaced? So like sort of productive maintenance or planned maintenance kind of tasks happen there. So I would say there's sort of broadly 3 large areas. And then within those, there's all sorts of directions people can go. There's agricultural stuff where data is expensive because it just takes so long. You have to wait until corn grows. Or, toxicology, you have to kill a rat. It's kind of expensive to kill animals to measure the toxicology. There's a lot of stuff, even not just R&D, but all over. There's a lot of directions.
So I just want to summarize. So there are 3 categories of industrial data. First are R&D experiments. These experiments are expensive, so we have very little data there. Then there is a kind of production data. That's the other side of the spectrum. And then the thing in between, I kind of missed it. What was that?
It's like you make a sort of, I haven't worked with this myself. I just know it exists. This is how people have explained it to me. I've worked on the 2 extremes. In the middle is sort of like a mock-up of a running process. In step 1 of your R&D, you've started developing this process. Step 2 is maybe you've built the sketch of a plant. The plant's
like
there, but you need
POC
to
kind of proof of concept.
Yeah, like a POC, like a tiny, instead of a whole giant warehouse, you've built a room running this process and you're trying to like fine tune how this should work.
So if we take this example of blue paint, then the expensive experiment part would be like trying combining different chemicals to see like the shade of blue is the right one, right? Then mock-up could be like, how can we combine it in a more automatic way, right? Instead
Exactly,
of just
right. How do we automate this process? How do
Yeah.
we get the right volume? How do we make sure that it's always this color blue?
And then production
Because I mean,
would
volume
be
can affect the color of paint. Also, paint is like paint. I mean, color is a hard problem, as we all know. Having paint, I've painted a few apartments.
I don't know why I decided to use this example, because I think maybe like 5 or 6 years ago, I interviewed with a company. It was a chemical company in a very small, like German village. And that was the only company in that village. And it was like a huge company, huge chemical company. And yeah, they were doing paints.
It's a good example. There's a lot of cool stuff with paints. There's actually another reason why it's expensive is one of the standard tests you do with paints is that it's called like the Florida test. And it's supposed to say, I mean, I think originally it was like we leave it out in Florida for 30 years, but obviously that's way too long for R&D length. So you paint some paint and you send it to Florida and you let it sit there for I don't know how long. But this is one of those, I mean, paint is a big application.
That's also an expensive experiment, right? If you live in Germany and
Yeah.
send in something to
Imagine, yeah,
Florida.
you have to ship it to Florida.
So Spain will not work, right? It has to be Florida.
No. There's something special. You can look it up. I encourage people in the audience to look up the Florida paint test or whatever. And there's like, you can see pictures of these huge fields. And I explain to you like there's special subtropical environment, blah, blah, blah. I don't know. I don't know the technical. I just know it exists and I was shocked and, you know.
Okay, so we already discussed that the industrial data is different from the usual internet companies' data. So the main difference is that there is a physical process that creates a physical thing most of the time in industrial data. Like, I don't know, there is an assembly line that creates a car, right? While in usual internet companies' data, there is like person comes, clicks, and then there is a recommendation. And
Yeah, and I
all
think
virtual,
I
right?
feel like there's also it's hard
Amounts of
to
data, right?
adjust what data you get
Uh-huh.
once it's productive. This is another thing that I think there's a lot of things that seem to surprise people. And one of them is you can have tons of data. So on the productive end, processes are not designed with data in mind necessarily, which I think is a difference with like CRM. You run experiments. You can say, what information do I actually need about my customers? You can adjust what information you're collecting very quickly. And in industry, you can't necessarily. If your plant's in another country, you need to explain what it is you want them to do. But like, I mean, what sensors are available to you? There's also issues of like, you might have a work floor where you've got a consistent process, but you have machines from 4 different manufacturers. And each machine has different sensors in different positions. How much do you trust your model that you're building with these? And then first, of course, you have to do cleaning and you have to like sort of pull this data together so that it makes sense as a whole.
Can you maybe give an example? I don't know to what extent you can be a made-up example, like of a process of creating something physical, and then what kind of things we can observe and record and use for.
Sure. I'm going to make one up. So this is a made up example. I was thinking about this, like, how do I make something up? Because I'm obviously I should not talk about work. So what's something that we all know and understand? I went with packing peanuts because this for me illustrates several problems all at once. So I have no idea how you make packing peanuts, by the way. I don't even know. Yeah.
Packing peanuts? I mean, you have peanuts and then you want to pack them
Oh,
somewhere.
no, I'm sorry. I thought this was a standard phrase. You know, when you open a box that's been shipped to you and it's not, there's various ways to pack things. One of them is with those big cushions of air. And one of them, there's these little styrofoam things.
So it's not actual peanuts.
They look sort of vaguely like a peanut. That's what we call them, as packing peanuts.
I got overly excited. I thought we would talk about peanuts.
No,
okay.
that would.
Well, packing peanuts is also a process that is, you need to add salt or roast them or whatever.
Okay, so this is a production process. So I have no idea how you make packing peanuts. I'm just going to make up a process because, right. Okay, packing peanuts. I'm gonna assume you extrude them or something. So there's something is mixing some kind of polymer, and then there's an extruder that spits it out.
Is an extruder for those like me?
Imagine your toothpaste. Well, this is
So
terrible,
you use
right?
kind
Like,
of okay, okay.
yeah.
Instead of toothpaste, you have like this material that.
Yeah, right. And then maybe something that cuts it off. I don't know. Maybe there's a mold. I mean, maybe it's a molding process. So somebody is going to come see this and with a transcript and tell us, in next week how you make packing peanuts. But whatever, we're going to pretend this is how you make packing peanuts. All right. It gets extruded, maybe it gets dried. You obviously might collect them together at some point, right, into a big batch of packing peanuts, and then now you ship those packing peanuts off. But obviously you need to measure the quality of your packing peanuts. I don't know what's important. What's important about packing peanuts? That they actually take up space, I guess, that they're not flattened.
And then they're like when you
Not
squash them,
squishy. Yeah. That they crumble, that they're not wet. I guess that would be good. But let's just say I want to make sure that they are not flattened. Maybe flattening is a big problem. Like you extrude them and they dry wrong. I don't know. How can I measure this? So at this point, okay, I've got some sensors I can put there. I feel like visual sensors are always expensive and kind of, but I don't know if it's true, but my impression from what kind of data is available is that other kinds of sensors are cheaper and easier to deal with. Like you might have weight, I guess, like it's rolling along a belt and there's a weight sensor underneath it and it says suddenly there was a drop in weight and like, okay, what happened? Did a bunch of peanuts not actually get extruded?
Maybe this thing that extrudes them, like you can measure the volume. Like how much each time?
Sure, yeah, you can. Yeah, there you go. You can measure like with each one is the volume consistent. Am I
And
always
then the weight,
extruding?
right?
I don't know, 10 grams or whatever, or liters, milliliters. I don't want a 10-liter packing peanut. Right.
So you monitor every step of this process, and then
you might, but you have to decide, right? Like there's a person designing this process, and this is also the thing: the person designing the process is not optimizing for the data collection necessarily. I feel like it's generally an afterthought. I have had this told to me by someone who runs a huge process that data is an afterthought. And they're working on it. This is like an industry-wide, oh yeah, we should really work on this problem. It's changing. But in general, historically, when you design a workflow, what you're optimizing for is you don't want the people doing the things to cross paths too many times, right? Otherwise, they're gonna slow things down by running into each other. So you design your shop floor full of machines and processes to minimize people running into each other. But that can make data collection and identification and tracking difficult. Why would you track one peanut? You wouldn't track one peanut, right? I wouldn't care about one peanut. I care about maybe like 10 grams of peanuts. But then that's sort of tough because at each stage of the process, maybe they get mixed up, right? Maybe you have data at the beginning that says this peanut was made with 10 milliliters of whatever gunk. And then later on the process, you have 10 kilos of peanuts, and you can say I guess what their weight is. And then, okay, well, how do I know what peanuts were in here? How do I pull this data together so that it makes sense all together? This sort of coarseness and fineness of data, and that you sort of mix things, there's processes that mix them together. Like when you're drying, you could imagine you put them in some big thing and they dry, and then you like have some kind of cycle to squish them around, mish them around, and then yeah. So I feel like coarseness and fineness of data is a problem. I mean, how you model the data when you finally want to work with it is a problem, or a challenge. Sorry, a challenge. I mean, it's exciting. It's really cool. I mean, there's also processes where, I mean, I was told sawing when you cut things is really messy, and it's a really hard problem to solve. How do you model anything with a process that does cutting? Because there's so much vibration. Like whatever sensors you have are going to have a lot of noise. I don't know if I answered your question.
This process, then this process produces a lot of data, and not necessarily all the data we need. But what I now wonder is, why do we actually care about this data? Do we want to make sure that the quality is good? Do we want to make sure that nothing breaks, or what's the?
So on the productive end, definitely quality. I mean, for the research end, it's like, how do I make the best product? And then on the production, like it's gone live. What am I doing? Well, maybe these, I don't know, maybe this thing that you're doing gets turned into something else later. I mean, this is often in the productive industry the case, right? I wouldn't buy a semiconductor, but I suppose I could, right? But I buy something that has this chip in it, right? And what you worry about is how do my QC parameters, how do my quality control, what does my quality control tell you about the quality control of the downstream product? That's a big challenge. So this is something, why do you care? But things like, okay, maybe packing peanuts are a terrible example, but I mean, I don't want to ship a box full of flattened packing peanuts because then they don't do their job. And so, yeah, quality control going out, quality control coming in of the product we're using to make our product. Also, yeah, stuff like can I improve processes? Like this example with I have a machine that's doing something and it needs to be changed regularly. Usually you do this, I mean, often you do this with just a rule of thumb, but maybe the costs are, I mean, especially now, right? Maybe costs are so much of a pressure that you really want to optimize this process and change this part one less time a day if possible. And so you need to keep an eye on, is this process producing anomalous pieces, right? How good is the quality? Is it within the range I need?
So basically, we use this data for monitoring, I guess, at the beginning.
Definitely.
Like for example, like we have 1 kilo or 1 liter of the material from which the peanuts are produced, and then we expect, I don't know, 1 kilo out, right?
Sure.
Or whatever volume.
Maybe.
And we can monitor it, right? And then we see, okay, like something is happening because we still put 1 kilo in, 1 liter in, but then something is happening, we have less or more or whatever, right? Then there are some charts and we can observe this. That's one thing, is like monitoring the process, making sure that things do not go wrong. And if something goes wrong, some of the metrics, I don't know, deviate from the usual things. You notice that and you can detect an anomaly, and then you can do something with this, right? Maybe send a technician to check what's happening. Right. And then
I'm just here nodding for the listeners.
The other thing is, you mentioned like, what was that? Like maybe qualities of this thing, like the when you squash them, they need to recover shape, right? So then how do we actually, maybe there is a part of the process that does that and we also record?
So I think, I mean, sometimes not every process has, we should also talk about tiny data. We should see, we should also talk about R&D, but this one's much easier because I think it's understandable faster. But my impression is there's two kinds of quality controls, sort of live on the conveyor belt or whatever, like during the process, you take a picture and you keep going and you leave the thing in the line. And there's a second kind where you destroy the product.
Okay.
Yeah. So that answers your question, which is, how do you tell if this is viscous enough or whatever? You take the thing out and you squish it. You take you'd imagine this giant bin of packing peanuts, and you take your shovel and you go in and you examine one shovel full of them and destroy that, so that you're only impacting a small percentage of what you're actually producing. And then of course there's a whole science around how much of a sample do I need? How often do I need this sample? Statisticians have certainly been working on this for a while.
So what I was going to ask is, as a data person, what do you do with this data? How do you use it? Like, do you build all these anomaly detection models that we just talked about, or there's more?
Yeah, I mean, you can certainly, there's people who, so adjacent to data science, or maybe in the broader data science family, you can also talk about like chemometrics, people who are computational scientists. I don't know how they would like to describe themselves, where they actually have the scientific background and have models for, based on this measurements, what do I expect about this quality of this product? So certainly each time, I mean, imagine when you physically have to reach in and look at things and touch them, right? It's expensive, and anything you can automate is great. Whether that's and my experience talking to people has been primarily quality control. I mean, I'm sure there's other things, right? Like predictive maintenance and things like anomaly detection. Why do you care about anomaly detection? Or maybe sort of volume of anomalies. If suddenly you go from your process has a 5% failure rate to a 20% failure rate, this is bad, right? And then but it's not something that you can. It's like a pre-warning, right? It's like your role is to give them a flag that says something's horribly wrong, and then they tend to have to. Then someone has to make the decision about what you do about it. Do you stop the machine? Do you stop the process? That also costs money. And those are things it really depends on the situation, what people need and what you can do.
I have no idea how it works in this industry, but at internet companies where I worked, usually there is a problem, right? So something, I don't know, like there's a problem, users complain, or I don't know, we want to improve something, right? Then we think, okay, what kind of data we have for that? And if there is data, good, we just use this data and try to see if we can use this data to solve this problem. If there is no data, we need to collect this data and then eventually hope that it will be enough to solve the problem. Does it look similar in industrial data? Like, I don't know, there is a problem that we need to make sure that the percentage of defects is at least less than 1%, and then
I was thinking, in answer to what you were just saying, I was thinking like a new requirement, right? So like your downstream customer says, actually, we really want to know, we really want to track X, right? We have some kind of, I don't know, sustainability requirements. And then suddenly it's like a new requirement. And then the first thing is, does our data tell us that, right? Can we actually answer your question with our data? And if we can't, what do we need to do? Do we need to add a sensor? Is it just one sensor? Can we get away with one? Can we like add a camera? Can we bring in some computer vision guys and gals? Yeah.
What kind of requirements? You mentioned sustainability. Like it means that I know the process we have for producing these packing peanuts is not too bad for the environment, right? So there is not too
Right.
much emission.
I mean, so let's pick another industry that I'm further away from. Like I imagine, like I think the airlines and also the train companies have started saying we're sustainable or whatever. How are they guaranteeing that? Or man, I bought something recently that said we're 100% sustainable. Your T-shirt, right? There you go. That's I mean, clothing is technically also a manufacturing industry. How do they certify that, right? Like, okay, the person making the shirt is taking fabric and thread and whatever from different customers and putting it all together. And so they have to go to each of them and say, we want this to be sustainable. And then they have to say what that means. And I think this is a developing label where people say sustainable means XYZ. And I don't know what it means. I haven't looked it up. I just threw it out there as a word. Like maybe it means it has to be organic. Maybe it means you have to be CO2 neutral. I don't know. So you take these requirements to your, cotton manufacturer, and then they have to go and see, okay, who do we buy our cotton from? How do they, like, what are the pesticides? What are the, whatever, blah, 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 blah. Do we even know that? I mean, I feel like a lot of the problem is we don't have no one thought about this problem at the time they developed the process. And so you have to figure out, can I approximate, can I create an avatar that answers this question given what I have? Or do I need to figure out a way to get that information going forward?
You have other examples, different examples for like this kind of problems
Requirements.
or
Let's do
requirements?
toxicology. So a friend of mine did this with his, well, not toxicology, what he's doing, like brain research. But this is all just like anything that involves animal trials. Pharmacology. I have never worked in this field, so this is another one where I'm making things up speculatively. My apologies to
Paint,
the
right?
people,
So paint
in
is
drug.
not supposed to be toxic.
No, but I mean, yeah, no, but paint can be toxic, right? I mean, lots of things can be toxic. But like
But it's
drugs,
better
they're
if
right,
it's
drug
not, right?
trials, right? People have to man, right. You have, I know in the States, right, we have changing rules on what you're allowed to have in various things. Like right now, at some point it came out BPA is terrible. So suddenly all the
BPA?
plastics,
What is
it's
BPA?
a chemical.
Chemical, okay.
That's all I know. All I know is that at some point we hit this like, oh no, this is terrible. And so all the chemical companies that made plastics had to suddenly make BPA free plastics for food safe things. And then this sort of sudden reactive So that's another example. So, right, toxicology. So I was just thinking like laws change, regulation changes, right? The allowable amount of X in Y changes regularly. And so you have to keep on top of regulations, what's allowed. And then, okay, can we still keep selling this thing? Can we still keep producing this thing with the current regulation? Can we adjust our processes so that we have no BPA or like only 5% BPA, or we just don't sell water bottles anymore because we can't avoid this?
Okay, so there is a new requirement about a certain, I don't know, percentage of certain element, BPA or whatever, and then you think, okay, now how do I measure this? And then maybe there is a sensor that you can add to one of the pieces of equipment that you have. You
But
add
this
the
would be
sensor.
actually a good transition into like small data, because at that point, if there's a law that says, or well, I don't think there was a law about BPA, but whatever, if there's a customer demand or a law that says we cannot have this thing in our product, then you have to go back to the drawing board. You have to go back into research and say, can we develop an equivalent product with similar enough properties without using the substance?
Okay. So how do we do this?
Experiments.
Like real experiments, right? Not A/B tests.
Real experiments. So that's I think that's also what's exciting about industry, is that there's like real science. I mean, so I shouldn't say it like that, should I?
Well, I mean, data science is it real science or not? Maybe not so much.
Sorry, natural sciences, right? Like
Okay.
people who have have spent many years in a windowless office blowing things up and losing fingers and whatever. Maybe not losing fingers, but
Hopefully not. Yeah.
it's a really different kind of place. And I think people really hyper specialize into their area, which is great. It's really valuable. It's really cool that people can explain to you like they give you a data set and you're like, man, this is really hard to model this. And they're like, yeah, we're not surprised because blah, 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 blah. Like the way that you even define a measurement can be highly subjective. Right, back to the point. The question. Sorry, you're gonna ask
The
it again.
question was, yeah, like how do there is a new requirement which,
Experiments. Yes.
yeah, we need
Right.
to change the process. And I imagine like in a traditional, I mean, in an internet company, it could be, for example, I don't know, 4 or 5 years, GDPR appeared, and all of a sudden, all of the processes of collecting data needed to be redesigned, changed. And yeah, for us, internet companies, it meant that going there, changing the code and thinking, okay, like do the new code we have and do the processes we have now satisfy the new requirements. But it's code, it's all virtual, right? So it's just changes in Git or whatever. But in this case, in industry, so it's actual scientists going there and starting experimenting with, I don't know, different chemicals or like other things.
Yeah. If you're in a situation, so going back to your blue paint, so let's say we had our blue paint and suddenly it came out that there's something in this particular blue dye that's, I don't
Does
know,
not
when
pass
it's
for the test,
exposed to something, water, it's toxic. I don't know, whatever. Something happens. We have to remove one of the components of this blue dye. All production on it gets stopped. We go back to R&D. So if it's something like that, where it's like you're redeveloping something, that's an interesting place to start, because then you do also have the old data, right? You have the historic data, you have the experiments that got you there, and maybe you can reuse some of that data to help you plan your next experiments.
What kind of data is there? Because it's different from the sensors data we discussed so
Yeah, it's
far,
super
right?
different. Yeah.
What kind of data is there? Like, for example, for
Okay.
paint or packing peanuts or whatever.
Yeah. Why don't I'll try to give you a spectrum. Oh, that's a great example, actually, is spectra. But it depends on what stage of the process we're at, honestly. My impression is when you're, and also, so I originally was doing stuff with okay, well, a year ago, I was working with polymers, so I know a little more about polymers. And there's a paper, which I think I added to the document for like linked recommendations on polymer informatics and its challenges. It's a really cool field. And right. So if you're doing something with chemicals, whether it's polymers or not. You have ingredients. Same for pharma. I mean, these are two things, two fields. Any field that has chemicals, right? You're also drug development, right? You have the ingredients that you put together. You have the recipe of how you make it. Like if you're baking a cake, right? If I tell you this cake is made out of, I don't know, this works with some recipes, but not all of them, right? Like cake is actually chemistry. But right, if I tell you it's like 5 eggs, 100 milliliters of milk, 100 milliliters of flour. I don't know. I made something terrible, some terrible slurry, right, at this point.
Mm-hmm.
But if I just tell you the ingredients and you know nothing about baking a cake, you're not going to be able to bake a cake,
Mm-hmm.
right?
Definitely.
So, so there's effectively two sets of data, and I think one of them tends to be held secret, which is one of the challenges of industrial data I wanted to come to, which is that there's the data you are allowed to see, and there's the data that you are not allowed to see.
You as a data person,
Data
you're not
scientist,
allowed
right?
to see
Yeah.
some data.
Yeah, and usually I mean, so baking a cake, right? Like,
Mm-hmm.
sure, the ingredients tell you something. They tell you, for instance, if you are celiac, if you're allergic to gluten, you know whether the cake contains gluten. So you can certainly do something with this information. But if you want to study the cake process, the cake making process and figure out if this cake is going to be tasty or not, I don't think I can tell you from the ingredients if the cake is going to be tasty.
Yeah, but what do you do with this information? So I imagine that there is a table. So like, I don't know, there are different sorts of ingredients with different
Sure, let's say eggs, flour,
yeah, and then
milk,
amount of
whatever.
X.
Yes.
I don't know, like for this cake you use 100 grams of this thing, like I don't know, sugar.
Mm-hmm.
For this you use 200,
Yeah.
and then like you record everything, you have it in a database.
Mm-hmm.
So what do you do with this? Like at the end, maybe you predict if cake is
So you also measure
tasty
stuff.
or.
So there's several kinds of measurements you can make. This is a beautiful
Mhm,
transition. Thank you for the question. Okay, so there's like material properties, like hardness.
mhm.
There's different kinds of hardness. Viscosity, which you can also different kinds. There's like surface tension. There's things where you can pull it. Like I imagine I
Viscosity is
wouldn't do
like.
this with a cake. I wouldn't pull my cake, but
Mhm,
certainly if I were an industrial cake baker, they exist.
mhm.
I probably would pull the cake. I probably would measure how much force it takes to pull my cake apart and then try to like work out backwards. Does
I
that
really
mean
want to
my
try
cake
that
is
now.
delicious?
Sorry.
Right? Because you can't just have people sit down and eat cake all day. You need
Mhm,
you need approximations to that that tell you something. Right. So there's material properties, like I said, viscosity or like the color, moistness, I don't know, material properties. And then there's also like application tests, which are
mhm.
I've put this thing into another thing and I've done something to it. So I don't have a good example of what would a cake application test be.
Oh, eating?
Maybe honestly something like you put it in a box and you ship it and then you take it out in for like I don't know you drive it around Germany for a month with improper improper conditions and then you measure if it's moldy. Like I could imagine that'd be like an application test for
Mhm,
like it's more extended, right? It's not a pure property of the cake. It's something
mhm,
you've done to it.
mhm. Okay,
This
so you
is
have
everybody's gonna be like, what are you really talking about, Rosana? I can give you like, I mean, yeah, I don't know if I can give you a real example. That's the thing.
but let's stick to the cake example. I think
Thank you.
it's yeah. So what we record, like in our data set,
Mm,
is the ingredients we use
yes.
and like how much of these ingredients we use. I guess then there are some properties of the process that
Mm.
produces the cakes. And then there are all these properties of the end result of the cake, like what happens if it's stretched, like I don't know, how
If
much
I
force we need to
I
put.
like this example of like we drive it around Germany and then we
Uh-huh.
measure if it's
Like
moldy,
all these
right? Because
things,
that's
right?
actually,
We
yeah.
do all these things, and then maybe one of the tests is actually, I don't know, eating the cake or trying to cut it, and then see how much,
Maybe cutting it's nice. I like that.
yeah,
Cutting the
like how
cake.
much
And
things
then you
are
can see how
there
much
on the knife.
resistance to the cutting.
Yeah,
Yeah, there you
whatever.
go. That's how you do
Like,
actually test a cake, right? You put the knife in to see if it's done.
so then like I can imagine like 20, 30 different tests, right? And you put all this data in a
Yes.
database.
Yeah.
What happens next? What do you do with this?
Um, Okay, well, first of all, it's there and they do whatever they do with it. And
Mhm.
I'm not a person who
But as a
works in the
data
lab.
scientist, what do you do this?
As a data scientist. So at that point, the reason that they're coming to you is that they want to optimize something. So this is like, I guess, a slight divergence to, if you like mathematical optimization, or if you learn mathematical
Mhm,
optimization, there are tons of those problems in industry.
mhm,
And there's also a fight on, okay, a gentle disagreement on whether mathematical optimization falls under the larger, ML, data science, AI world. Putting those aside, it's really important. I mean, I had an interview somewhere else where it was like a traveling salesman problem. We have logistics, we have, 10 places where we store stuff. We have, how many trucks do we need to get things from A to B in the correct time? We want to minimize that, obviously, for various reasons. And what route should they take? So this kind of like planning, graph theory, mathematical optimization, these kind of problems come in at this point.
mhm.
Coming back to your actual question,
Yeah.
it's an
So
optimization
maybe,
problem.
but
They want to say they want the best cake.
mhm,
And they
yeah.
come to me and they're like, we want the best cake. Tell us, here's our data. We've done our
Mhm.
experiments.
And best, do
Prefer,
they define what is best or?
yeah. But before that even happens, in an ideal world, let me tell you the ideal workflow, which does not always happen, is they first come to you and say, we want to run experiments such that we can then determine the best cake relative
Mhm,
to these requirements. And if they do that, then you can do a design of experiment.
mhm. So I was thinking of a situation then, for example, when you bake a cheesecake, sometimes there could be cracks
Mm,
in the cheesecake after you
sure.
bake.
Mm.
And then
Right.
maybe
So
you,
best could be like minimizing cracks, so there's no
yeah,
cracks, right? So you've got
but
things that
then,
you measured.
yeah.
So what do they want to optimize? They want maybe the lowest cost possible
Mhm,
relative to the best taste
mhm.
and
Then
things
fewer
you can measure,
cracks
right?
and
The
then
least
like,
cracks, the
mhm,
best color, right?
mhm.
Maybe you want a shiny
Viscosity.
cake, right? If you got like one of those, I don't know if you watch baking shows, but there's like these baking shows where they make really shiny cakes, and I don't know how they're shiny, but they do look really tasty. So maybe you want a shiny cake, and then you can measure the shininess. There is a way to measure that using light and reflection and
Mhm.
sensors.
Okay, so you have all these requirements,
Hmm.
and then you have an optimization problem, right? So
Yes.
how do you combine your ingredients in such a way, or how you optimize your process in such a way that you still satisfy all the requirements, and then you maybe maximize some of the things, you minimize some of the other things. So it's like, is it called linear programming? Is simplex method,
Some of
things
that.
like that?
Yeah. Related.
That's what you use for. What do you typically use for solving the
I'm
problems?
gonna say we're coming a little too close to things
But
I
let's
probably
say,
shouldn't talk about.
well, let's say for this hypothetical example of a cake, what would you use?
No, I'm not. I just
Simplex method. What do you use the simplex method?
I think honestly, and I think this is probably, I mean, obvious that we have tools that help us. I mean,
Hmm.
there are companies who specialize in
Hmm.
doing mathematical optimization and making it super easy, and we might make use of their offerings to make our lives easier. Then what are we actually doing? Well, we're setting up the problem,
Hmm.
and if there's not enough data, there are ways to deal with that. So that's where the data science comes in as well, and then you hand all that to a solver.
Hmm. Okay. So there is some industrial solver. There is a company who maybe specializes at optimizing these kind of processes, right? And then for you, what you need to do is define the problem and then put the data there, and then I don't know, click a button and then watch the solver find the best solution.
I mean, you if you only have like 10 data points, you can't feed that into a solver. So
Hmm.
there's modeling in the middle, and that's where data science comes in
Hmm.
as well.
I see. What kind of modeling is it? We're creating new data?
Lexi,
That's the most interesting stuff.
I know, but I'm not officially here to officially talk about
Okay,
this.
yeah,
I haven't had
understand.
like a deep heart-to-heart discussion with communications about what I'm allowed to say. So
Hmm.
and we're recording, and this is live. I have no way to like, edit this out later if I say something I'm not supposed to.
Okay, understood. Mm, okay, now I'm kind
I
of.
don't know. I'm like, I have to. Can I answer your question at all? I mean, we do have I mean, sorry. Now I'm talking, from my company's perspective. There are hackathons that are faced to the outside world. And that's not a bad place to learn about what kind of modeling one does. And there certainly are, I mean, with tidy data, the answer is not, I mean, this is obvious. This is not secret that the answer is not going to be a neural net unless it's something that's been pre-trained and you can do transfer learning. So, I mean, make good friends with statisticians if you think tiny data is exciting. And I think there's no one answer. And that's what I also found quite exciting. I mean, we have a working group at work to talk about, hey, I have this problem. What do I do with it? And it's not just optimization. There's also, can we do prediction? And sometimes the smallness of the data is actually, we have like an infrared spectrum, like some kind of measurement that's like a time series. So it looks huge, but it's actually small. And then like, how do I take this data and figure out things from it? I mean, there's a lot, I came wanting to say there's all these cool challenges, and then
well,
hopefully
I
I've said
imagine like building a model, a binary classification model that says with these ingredients and this process of baking the cake, will it crack at the end or not? And then you have a
that's
model.
another problem. Yeah. So if you don't want to do optimization, if you don't want to do what's the best formulation for this cake, which is what I was working on, then and what you want is given these things, what's going to happen, right? Will the cake crack? Completely separate question. I mean, we have those questions as well. And you can also see how like, well, I think something I was sort of struggling to explain to someone the other day is that you don't, with this kind of work, you don't necessarily have a high volume of in production models, which was my other, like back when I hung out in the MLOps community, I was trying to figure out, can I use this structure for my problems? But if you don't have high volume things because you only have tiny data, or you have a consulting project to do this one thing, you don't need a model that sits there and tells you the optimal solution. You have one.
Well, since you mentioned MLOps, I'm wondering, so in internet companies, I know that people use Kubernetes and all this stuff, cloud, for deploying the models. I imagine that this is a pretty different situation in real industry.
If you go to the productive side, I would say it should feel to you like everywhere else. So if you're coming from anywhere else in industry and you're like, I want to come, this is industry is sorry, in IT, can we call it IT? In the data space, if you're working in the data space and you're used to how people deploy things, CI/CD, MLOps, whatever, and you like working in that space, and you're looking over here and saying, manufacturing, what can I do? This, I would say definitely the productive side where you're generating, I mean, right, depending on the speed of this conveyor belt, right? And if each of our packing peanuts has at least one, I mean, it's going to have like a time series associated. I mean, right? It's giant piles of data, right? At one point I was so excited because I was using Spark to pivot like 2 terabytes of data, and that was like a day of data, right? So there is big data, and there are these things where people have models and they're doing experiments and they're constantly deploying and all that it's there. But I would say like the tiny data should feel obvious that that's not necessarily the challenge that you're dealing with. You're dealing with things, and often it's like, I mean, I knew someone who was embedding their model into a software that was being used for visual inspections. So there's also sort of like deployment in kind of like a local sense as well, like not a big.
No, understand. So for the production settings, you probably have all these Kafkas and streaming data and then
Again, I can't
Sparks.
tell you what our stack is, but yeah.
It doesn't matter. Well, what I mean is like there are some systems that maybe you will find in other places like internet companies
right.
too, because you want to react to this data reliably, right? So you want to observe this data, you want to make sure like all the alertings are set and like all the models work real time as the process is actually happening. And then there is other side of the spectrum, which is these experiments where maybe you have like 10 data points and then you put them in Excel and then you look at them and then
you don't even just look at them. I think also that's the, and if you want to, I appreciate your summary, and I like what you're doing and that you're trying to bring us to an end. But I mean, I think part of what's really interesting is you have to learn about the data. And I think this is also like, if you're a scientist now, and by science I mean a real if you're a physical scientist, if you're a chemist, you're a physicist, I don't know what other sciences we have, sorry guys. um, it's a really powerful place to be, because then you can learn the machine learning methods, and then you have the background, right? You go into it. People don't write everything down, right? Everybody knows when you start making whatever it is, when you start making blue paint, the first thing you do is you heat up the container to 100 Celsius. I don't know, whatever, but everybody knows it, so we don't write it down. So if you are a chemist who did this thing, then you know that thing, right? You know all the context, you know the baked in knowledge. And it's so it's more than just the Excel file. I think coming to, and I've talked to people about that and their challenges with past projects, and they're like, yeah, we just threw a data scientist at it and got nowhere. And it's because they didn't ask the right questions. And I think that's
And data
also,
scientists had no idea about all this hidden knowledge, right?
you have to work really closely with your partners. You can't just like, you can't just be a hermit data scientist. You have to be
Just
incredibly engaged with your partners and interested about their processes and ask them.
So you cannot just open your CSV file with pandas
No,
and then
you
throw it
have to.
to
You no,
XGBoost and
I feel like
then
the process is, you open it, you first, you talk to them and you ask them what the problem is and that you understand it, and then they explain the process to you, and what everything means, and then you go digest it and you do your EDA and you come back and you're like, these things are both called shininess, and like shininess 1, shininess 2, and their ranges are really different, their distributions are really different. What is this shininess? Like, what is it? A data collection problem? Is it like it's impossible to, like, or is it like a definition? Like, do I just not understand the difference? Should I be taking the difference? um Also, things like people measure stuff like after 6 days, after 12 days, after a month, and then they view these as really separate measurements. But to me, they're just the same measurement, but over time. And like, is which way you should model it? Like, how do I cut the data? How do I model it? How many models do I need to bring together to actually give what they need? There's a lot of really cool challenges.
Are there any open materials about this subject? I don't know, courses, books, whatever,
Oof,
that people can just go and learn about
there
this?
must be. You should.
Well, okay, I should ask it, do you know any, and can you recommend?
No. I mean, I'm happy to go try to figure the answer to that question. And I wish I had gotten you an answer beforehand.
Mhm.
I did put on this document, there's this machine learning repository which has a very realistic data set on sensors, on, like, it's from the semiconductor industry. You can go play with that if you want to build yourself an anomaly detection model for whatever the process is that they're modeling. There was a Kaggle notebook
UCI
associated to that.
SECOM
Hmm.
dataset, right?
Yeah,
I'm
exactly
going
that. So
to
that's a
post
short
this now.
answer,
All right.
but there must be a book. I just don't know what it is.
Okay.
I mean, I did a lot. Yeah.
Well, we will release this interview in a couple of weeks as a audio-only version with transcript and
So
whatnot.
before
So
then,
if
I will
by
do my
then
best.
you find anything interesting, then please let us know, and we will add this to the show notes.
Yeah.
But by the way, I just shared the link in the live chat, and I'm going to put this in the description too, to this Kaggle.
We're at the end, but there was a Slido. Did you check the questions? Do you want to do like a quick?
Yeah, there was a question if there's one, I don't know, it's a bit personal if you want to answer that or not. Are you the only woman on the team?
In my current team, no. In my larger previous team, definitely not. I'm not gonna share a picture, but we had a dinner on Friday, and let's see, there were 10 people and half were women.
Okay. So gender balance
I
is
mean, gender balance is fine. I don't think it's not always half. I think some of this is, of course, like who actually comes out to dinner, but it's not terrible.
Okay. Yeah, we have more questions, but I think we already answered some of them.
We're done.
And
Okay.
for the rest, like, can you talk more about your decision to work in industry? It will probably require another episode, another interview. So maybe we can just wrap up.
Yeah, I mean, we've why industry? I mean,
You have time. maybe
I mean, we mean
like
productive industry,
3,
not
5 minutes.
I mean, there's sort of two questions depending on how you define industry. Do we mean just not academia, or do we mean productive industry?
Well, I guess maybe both.
Okay, so not academia is I like it all right here. I've reached a point where the next academic position I could take would have been 6 months with a possible renewal for an extra 6 months, moving to another country, learning another language. And I thought, I'm not, no. So at that point, obviously, I need to do something not in academia. And then why, why I started where I started is I asked everybody. I applied for everything, and I asked everybody, do you know people who are in industry? Oh yeah, I know this guy. Oh yeah, and I talked to him, and I mean it's over someone I knew.
It was just
And
something attractive to you, like you thought, okay, this is something I want to work with because it sounds way cooler than, I don't know,
6 years ago,
your
it was just
usual e-commerce store.
I need a job. 6 years ago was I need a job, and then 3 years ago was the way the project was pitched to me was, hey, we're effectively like this little research group in industry, and we have all these POCs, and we want someone to help us try to figure out how to turn them into productive product projects. And I thought that sounded really cool.
It does, yeah.
And that's what got me into it. And then I like the people. I think I have to say, um, I hang out with a lot of physicists in grad school. If you're listening, hi. And I, there's a lot of, physicists and chemists, just a different worldview, the people that you end up interfacing with in data science, and as well as like the people touching the data and generating the data. It's just a very different flavor of workplace. I mean, my previous employer, the people who worked on the shop floor were walking around in these ridiculous shiny jumpsuits because it reduced it's something that the fabric reduces the static. But so, like people just wear whatever, right? Like people show up in hiking clothes. Like it's just this very casual. It's much more about, the work and the science. It's very, the people. The people is the answer.
I also guess that it depends on where you are geographically.
Yes.
When it comes to Germany, for example, if you're in Berlin, there are not so many this kind of industry companies,
Yeah.
right? So you're probably, you'll end up working
It
for an
must.
internet
It
company.
must. There's like a little bit, but there,
A
it's
little bit,
more
but like you need to be specifically looking
a little
for
further away.
this. Yeah, not
Yeah, like
just,
closer to Dresden or something.
yeah.
There's a few down there. You have to get outside of like
Hmm.
Berlin itself. Yeah.
Yeah, well, I think that's all we have time for today. Thanks a lot. That was a really good discussion. I'm very hungry now after talking about
Yeah.
peanuts and
Same.
cakes. So probably should go uh, eat something. So yeah, thanks again, and thanks everyone for joining us today. Um, yeah, it was nice talking to you.
Yeah. Likewise.
See you soon.
Ciao.
Goodbye.